Good afternoon, class. Here's Calculus 1. Final exam review, covering from section 2.1 to 6.1. Here's the last part, chapter 5, integrals, 6.1 areas between curves, and reminding everybody of the pledge that when we take the exam, we take the exam on our own without any help from anywhere. So having said that, let's just quickly go over the questions we've seen. There's really not much brand new. We want to use geometry to evaluate this. So what do we have to know? First of all, the function is this, and the interval of -3 to 3. And we're going to prove what type of a function we are dealing with. And so, first of all, we're going to call this y. And reminding everyone, a circle is in the form of, in the center that's 0, 0, x squared plus y squared equals r squared. Different center, h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. And so we have those, the area is pi r squared, circumference is 2 pi r. And in this case, if you square both sides, and then move the minus x squared, you get to this, which proves it's a circle centered at 0, 0 with the radius 3. And so the other thing that I want to mention, the top portion has the positive one. If you take here the root of y, and the bottom one takes a negative. Also, we have the right and left. Here's the right side. Here's the left side. And so anyways, this is a graph of a semicircle of radius 3. So pi r squared and times 1/2 gives us the answer, which is 9 pi over 2. So that's pretty straightforward, everybody. We are given a bunch of definite integrals. So we want to find the integral of 1, 2, 3, 3 times f of x dx. We take the 3 out, and this part is 6. So 3 times 6 equals 8. In this case, we cut it into two pieces. We take the 2 out, minus we take the 4 out. And now this part, again, we are going to replace it with 6. This part with -4. The answer is 28. The integral of 1 to 7 f of x dx is the same as 1 to 3 plus 3 to 7. 1 to 3 plus 3 to 7. Notice those are in common. And so you add up and you come up with 50. What about 3 to 1 is by the theorem, the negative of 1 to 3 f of x dx. So whatever this number is, negate that, and -6 is the final answer. F of x is a piecewise defined function. We want to evaluate the integral of -2 to 2 f of x dx. So obviously, we are going to cut it into two pieces, because this is from -2 to 0. We're going to evaluate it from -2 to 0 using the top piece, and the rest of it, the bottom piece. By the way, just in case, if this was -infinity, we would do exactly the same thing from -2 to 2, and if it were positive infinity. So having said that, obviously, this is 2x from -2 to 0. This is 4x minus 1/3 x cubed from 0 to 2, and we're done. This is the only calculus step. We plug in, we evaluate it, and we get 12 minus 8/3, which is 28. I'm assuming the part that is elementary algebra or basic math, nobody has any problem. All right, we want to take the derivative of the integral of tan t dt as it goes from 1 to x squared plus x, and reminding you of the fundamental theorem of calculus. There are two of them. One of them is the definite integral, which gives you a number, and one of them, the derivative of a to x f of t dt, it gives you the function at the upper limit back. Okay. However, if the upper limit is not x, is a function of x, then you plug in that function of x and then times g prime. This is by the chain rule. So the function f of t is tan of t. So tan of the top function x squared plus x. And then because this is a function of x, its derivative is 2x plus 1. And we rewrite it and we're done. What if you're taking the derivative of the integral where the bottom and the top are both functions? Over here, the bottom wasn't a function. Then we follow the following theorem. The d dx of the integral of g of x to h of x f of t dt, you plug in the top function f of h of x and times h from, this is by the chain rule, minus you plug in the bottom function f of g of x times g prime of x. So this one, first and foremost, the function f of t is t squared. Replace the t with sine, then times the derivative of sine, which is cosine, minus, now replace it with the bottom one, tan squared, and then times the derivative of tan, which is secant squared, and there's nothing to do to simplify it further. We are done. What if the bottom is a function and the top is not? We use the theorem and we interchange those and we make this negative. So that's it. So take the sine x to the top, make this negative, and again, follow this one. The function is this f of t. Now replace the t with the top function. So you get minus, you keep the sine, square root of 1 plus sine squared x, and the derivative of sine, which is cosine x, and you rewrite it and you're done. A particle moves along a line so that its velocity is given as such. Measure the meters per second. Find the displacement of the particle during the time period between 1 and 4, and then the distance. We'll discuss the difference between the two. Displacement is the integral of a to b v of t dt, but distance is the absolute value, because displacement, if you go from point A to point B, this is A, this is B, this is the displacement. But if you go this like so, that is the distance, you have to add them up. So that's the concept. So having said that, we are going to remind everybody, let me erase my word. As I mentioned, the distance, you're going to add all of them, A1 and A2 and A3, but the displacement A1 and A3 add up, but they have to subtract A sub 2 because it's on the negative side. So in short, S sub 4 minus S sub 1 is simply the integral of V of t dt from 1 to 4. So you plug in 1/3 t cubed minus half of t squared minus 6t. Evaluation from 1 to 4. I'm going to leave it for you to show that it's -9/2, meaning the particle moved 9/2 or 4.5 units, meters towards the left. What about the distance? We're going to go with the absolute value. To go with the absolute value, we have to know where the function is positive, and we use it, and where it's negative, we use its negative. So it's opposite. Absolute value of x is x if x is greater than or equal to 0, and minus x if x is less than 0. So having said that, we go with the factoring and we use the sign graph. This function is 0 at -2 and at 3, although we are going to go from 1 to 4, but let's just do this in general from negative to positive infinity. Again, we just want from 1 to 4, and time is positive, but just for the sake of argument. So basically, you put negative infinity to infinity, and the two numbers that you have here, t equals -2 and 3, in from smallest to largest. This is degree 2, has two answers, therefore they will alternate. So you have to go with TPs or test points, TPs. But for example, here you would use -3, 0, and let's say 4. Just use this one and observe. So if I put the 0 here, I get -6. So this is negative, they will alternate. So that means over here and over here, I use the positive. Because it's going to go from 1 to 4, this one I don't have to worry about it. So it's really starting, let me erase my word. It's starting from somewhere here, which is 1, to somewhere here, which is 4. So From 1 to 3, negative. So that means we use the opposite of that, and the rest of it is positive. We use the same thing. So 1 to 3, the negative of that is minus t squared plus t plus 6, and 3 to 4, the function itself. So this is negative 1/3 t cubed plus 1/2 t squared plus 6t, and this one we already have it like so. Evaluate this one from 1 to 3, this one from 3 to 4, and 61 over 6 is an exact answer, roughly 10.17 meters. That's the distance that it covers. F of x is given, we want to differentiate. The idea is that how to differentiate the exponential. Remember, the answer is always itself. You multiply by negative 0.2, right? Because that's how the differentiation works. The derivative of sine is just cosine, so minus cosine x. I just want you to see the difference between the two, and we're going to rewrite it, of course, as minus 0.8 e to the power minus 0.2x minus cosine x, and this is just remote. Now, if I want to integrate that, I want to integrate this times dx. And the only reason I put them next to each other because I want to compare and contrast, because sometimes students are mixed up. So in this case, again, differentiation and integration, you get the same answer. Differentiation, you multiply by negative 0.2. This one you divide. So if you have the integral of e to the power of kx, you divide by k. So this one, you divide by k. That means the same answer divided by negative 0.2. Minus sign gives you positive cosine and a constant. And division gives you negative 20 divided by minus 0.2x plus cosine x plus a constant. We are done. Let's make it into an initial value problem by coming up with one pair. F of 0 is 20. That means you have the pair 0, 20. This means so replace the independent variable, which is x, with 0, and f of x or y with 20. You know this is 1. Cosine of 0 is also 1. And you end up with c being 39. This is what you get. This is a general solution. And this is a particular solution. So very straightforward. All right, the integral of minus 2 to 2 x to the power of 6 plus 1 dx. When we have an integral from negative to positive of the same value, it is helpful to know the following. Integral of symmetrical function. F is continuous on the interval of minus a to a. If f is odd, f of minus x is minus f of x. The integral of minus a to a f of x dx is 0. So take a look at this one when it's odd. This and this one are identical, but in opposite side. This is considered positive, negative, they cancel each other. On the other hand, if it's even, f of minus x equals f of x like this one, then the integral of minus a to a is 2 times the integral of 0 to a f of x dx. So whatever this one is times 2. So one might say, so what's the big deal? Normally, when one of the limits is 0, it's a lot easier to calculate it. This is an even function because if you replace the x with minus x, nothing changes. So instead of evaluating from negative to 2, negative 2 to 2, we're going to evaluate from 0 to 2 and multiply it by 2. So that makes it easier. And 1 over 7x to the power of 7 plus x. And again, times 2, plug in, and evaluated at 284 over 7 is the final answer. This one, we don't have a way to evaluate it as far as calculus 1 is concerned. But this is equal to 0. Why is that? The moment you come across an integration which is very difficult, and the bottom and the top are opposite, this is minus a, this is plus a, in this case minus 1, plus 1, you're hoping that this is an odd function. So this is the function f of x. And if you evaluate f of minus x, tan of minus x is minus tan x. The bottom doesn't change, so this is minus f of x. It's an odd function, and that's a proof. The answer is 0. So you have to prove the function you're dealing with is an odd function. So having said that, let's look at this example. We make up two fractions. This one divided by this one divided by this, and the square root of x is x to the power of 1/2. This has exponent 1, so this one becomes x to the power of 1/2. This one is x to the power of minus 1/2. Everything we've done so far, elementary algebra, we got it ready for the next step, which is the integration. This one is 1 over 1/2 x to the power of 1/2 1 over 1 half plus 1 x to the power 1 half plus 1. This one over negative 1 half plus 1 x to the power negative 1 half plus 1. And then since we are done, we add a constant. We're done. This is it as far as calculus. So 1 half and 1 is 3 halves. Negative 1 half and 1 is 1 half. Division by 3 halves means multiplication by 2/3. This one means multiplication by 2. You can rewrite it as x to the power of 3 halves is x squared of x. X to the power of 1 half is square root of x, just in case. So that's pretty straightforward. We are going to move on, everybody. All right. The concept of a substitution, the integral of f of g of x times g prime of x dx, this is the u. It's the integral of f of u du. The very first thing you have to do, you have to write down what is u and du. So tip, look for a function u equals g of x anywhere in the integrand and its derivative du, or g prime of x multiplied by dx. So having said that, when you have polynomials, the more complicated one, in this case, x squared plus 5 is a choice of u. As you know, if you differentiate, you get 2x. That means du is 2x dx. We move the 2x so it becomes clear for the reader that this is u, this is du. So we are looking at u to the power of 30 du, which follows the power rule. 1 over 31 u to the power of 31 on a constant. Reverse substitution gives us the final answer. What happens when you're dealing with a fraction? Well, either it's a polynomial or not. The very first thing is to simplify. This can't be simplified. The denominator is a choice of u. Notice the derivative of the bottom is the top. And so du is the top times dt. We are going to rewrite it so it becomes clear. The top is du, the bottom is u. The answer is a natural log. And you replace it and you're done. Bear in mind, a 5 plus e to the power of t is a positive statement. In fact, it's greater than or equal to 5 always. Therefore, you can drop the absolute value. What happens here, you want to simplify, you can't. How do you know you can't simplify? By the way, even if you can factor the bottom, it has to have a factor of x plus 1 to be simplified. So the reason we can't, I'm going to remind you of the quadratic formula. And the discriminant, b squared minus 4ac is positive. We have two distinct real solutions. If it's 0, 1, if it's negative, none, or two complex solutions. And if it's a perfect square number, it can be factored. So if we look at this one, a is 1, b is 2, c is negative 1. So b squared minus 4 times a times c is 8, which is not a perfect square, so it can't be factored. The denominator is a choice of u. If you differentiate, you get 2x plus 2, or 2 times x plus 1, which makes du the same thing times dx. And we're going to rewrite this by putting the dx at top. As I've mentioned it many times before, when a number is missing, such as 2, you can put it in and undo it with its reciprocal. And now this part is just the same as this one, natural log. Replace it, you're done. Bear in mind, you have to keep this, because keep the absolute value, because the statement x squared plus 2x minus 1 can be positive or negative. Now, if you have a reciprocal of this, you have to do long division. If you have a reciprocal of this, you make up two fractions. This one and this one. So that's very straightforward. And you can see the answer easily. Minus 5 e to the power minus t plus a constant. And we are done. What happens when natural log is involved? That is the choice of u. Its derivative is 1 over x, which makes the u 1 over x dx, or dx over x, however you want to write that. To make sure everybody is clear as to what we have, we rewrite it so it becomes clear you're dealing with u squared du. The answer is 1/3 u cubed and a constant. Replace it and you're done. What about part B? The very first step, can I simplify? The answer is no. Notice the denominator. If you differentiate, you get the numerator. So the denominator is the choice of u. The numerator times dx is du. Rewrite it by putting the dx to the top. And now again, the answer is a natural log. You can lose the absolute value because the expression is positive. Otherwise, you must keep it. What about this one? First, I want you to notice the independent variable is theta. So 5 gives you 5 theta. 2 cosine theta, 2 sine theta, and a constant. What about this one? Anytime you have e involved, normally it's derivative, it's exponent. In this case, x to the power of 5 minus 2 is a choice of u. Its derivative is 5x to the power of 4. Du is 5x to the power of 4 dx. So we're going to move x to the power of 4 so it becomes clear to the reader that 5 is the only one missing. Again, in most texts, they solve for dx. I don't. 5 is missing. Put the 5 and undo it with its reciprocal. Now you have a simple case of e to the power of u. The answer is itself. 1/5, you keep it. A reverse substitution gives you the final answer. Again, natural log is involved. That's the choice of u. As you know, the derivative is 1 over x plus 1 times 1, or simply 1 over x plus 1. So du is the same thing times dx. And we are going to rewrite this. It becomes clear to everybody that we have u times du. And what are the new limit? This, of course, gives you half of u squared. And 0 here gives you ln 1, which is 0. 1 gives you ln of 1 plus 1 or 2, ln 2. So it's half of ln 2 quantity squared, and we are done. What about this one? Notice cosine squared can come up, become secant squared, because cosine and secant, they are reciprocal of each other. So if you choose the denominator to be u, the derivative of 1 is 0, the derivative of tangent is secant squared, therefore du secant squared dt, and that means the numerator is du. So again, a natural log, plug in, and keep the absolute value, and we're done. Ln of absolute value of 1 plus tan t plus a constant. All right, what happens when we are dealing with trigonometric functions? Well, if the argument of a trigonometric function has an exponent, it's a function of x. Doesn't have to have exponent. It's a function of x. That's the choice of u. Its derivative is 2x, which makes du 2x dx. We move the x, and it becomes clear to everybody. This is sine u, but this is not du. You need a 2 and 1/2, and it's a number. You can do that. The derivative of sine is cosine. The integral is negative, so negative 1/2 cosine u plus a constant. Reverse substitution gives you the final answer. However, in part B, sine and cosine, both of them are there. One of them has an exponent. The one with the exponent is a choice of u without the exponent. So sine x, the derivative is cosine x dx. And you notice is u squared du, 1/3 u cubed and a constant, and you're done. So if sine and cosine, both of them are present, that's what you do. For example, here, u is cosine, its derivative is negative sine, which makes du negative sine x dx. And so this one is fine, except doesn't have a negative sign. We can put a negative in, negative out, because the product is positive 1. So you're dealing with the power rule, and negative 1 over 21, u to the power of 21 and a constant. Replace it, and you're done. If both of them have exponents, you have to use trigonometric identities to make one of them involving the exponent 1. Remember, sine, the derivative is cosine. The derivative of cosine is negative sine, so you can deal with the negative sign. It's not a big deal. Many fish grow in a way that is described by von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum of 30 centimeters, this equation predicts the growth rate is 29 to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Well, We let L of x represent the length, then its derivative L prime or dl dx is this one, and the initial value is this one. So we use the fundamental theorem of calculus, also known as the net change theorem, and we find the amount of increase over the course of 4 years. It's the integral of 0 to 4 of this expression, of course, times dx. We integrate, we evaluate from 0 to 4. That's the amount of increase. Initially, it was 1. We added, and because we want 1 decimal, 4 next to the 6 goes to 5. And we're done. However, I can find just the integral in general to find the function with the initial value. So this one, we already know this is the answer. So we're going to say this one plus a constant with the initial value L of 0 equals 1. This is the general solution. Now using this, we can get to a particular solution. Obviously, C becomes 30, plug it in, and now 4 years, L of 4 will give you the same answer as we got here. So the advantage of that, as it has been mentioned a number of times, is very simple. If you want it at different age, 4 years, 5 years, 6 years, just plug it in here. We want to evaluate the integral. That is a definite integral. That's a number, and this requires a substitution. Please understand, we have x and 25 minus x squared, which is more complicated. That's a choice of u. Its derivative is negative 2x, which makes the u negative 2x dx. We're going to move things around, and we notice this one is missing negative 2, and we're going to put negative 2 as well as negative 1/2, because the product must always be 1. You can only do that to numbers, and we write it in this fashion. We're going to finish it without writing the limits. The purpose of that is to, again, remind you the limits are different now. You can't use the original limits. And so this is u to the power 1/2. You know, we've done this a bunch of times. 1 over 1/2 plus 1 u to the power 1/2 plus 1. This is 3/2. This is 2/3. Multiply it, and this is what you get. Now you can go back to original and use the original limits. Or if you plug in 3 here, 3 squared is 9. 25 minus 9 is 16. You put the 4 here, 4 squared is 16. 25 minus 16 is 9. Plug in, evaluate. This is square root of 9. Wait, these a different color, which is 3. Cubed is 27. This is 4. Cubed is 64. Their difference is negative 37. And their product is positive 37/3. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek, as seen in the diagram. Find the maximum area that can be enclosed. I can't emphasize this enough. If this is given, so be it. Otherwise, you have to come up with the drawing to come up with your variables and the definition. So we're going to define the sides of x and y, and here's the area. The objective is to maximize the area, which is x times y, the width times the length. Now, we have 240 feet of fencing. We have 1, 2, 3x, and only 1 y. This side doesn't meet. So this is a function of 2 variables. We're going to solve for y here and put it in here, and we call it a of x. And x is between 0 and 80. Why is that? X represents a dimension, must be positive. If you set this equal to 0, you get 80. And if you choose a number larger than 80, this becomes negative. The area, the product becomes negative. So distribute, because we want to differentiate, and we get 240 minus 6x, set it equal to 0. That's your critical point. So what we are dealing with is an open interval with only one critical point, which makes it not only a local, also an absolute. But is it max or mean? Let's go with the second derivative. We get minus 6. Negative means concave down, means maximum, because it looks like that. So maximum occurs when x is 40. So if I put it here, 3 times 40, 120, subtract it, and you get y to be 120. So the maximum area is the product of the two, which is 4,800 square feet. So that's pretty straightforward, everybody. And so we are going to move on. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. I'm going to remind you of a couple of things that we should know from geometry, algebra, you name it. Use a rectangular solid or prism. If you want to find the volume, the width times the length times the height. If you want a surface area like gift wrapping, 2 times the width times the length plus the height times the length plus the height times the width. If all sides are equal, the name is cube, where the volume is s cubed and surface area is 6s squared. So that's just to let you know what we already know. And this one, the base is a square. So this is x times x. You're going to define your variables, and this is the height. So you have to have a drawing. You have to define. And it's an open top. So we want dimensions that minimizes the amount of material. Gift wrapping. Normally the gift wrapping for this one, if you look at this face, there are 4 faces around it, lateral surface, x times h. 4 of them are identical, 4xh. The bottom is x squared and the top is x squared plus 2x squared. Because it's open top, only 1x squared. So the objective is to minimize the surface area of, which is 4xh plus x squared. Then, subject to the volume being x squared h, the area of the base times the height, which is to be 32,000. Having said that, we're going to solve for h, because this is a function of 2 variables. We're going to make it a function of 1 variable. X cancels out the x squared, makes it x. In other words, the exponent drops. We get 4 times 32,000, 128,000 over x. And in order to get it ready for differentiation, we're going to bring this up. And of course, x represents dimension, must be positive. That means 0 to infinity. Differentiation gives us -1 s prime of x, -128,000 x to the power minus 2 plus 2x. And this is the same as this one. Take a common denominator. Now, s prime is 0, the top is 0, s prime doesn't exist, the bottom is 0, the bottom can't be 0. It's not part of the domain, so the top is 0. 2x cubed is 128,000, and x cubed is 64,000, and x is 40. So we have an open interval with only one critical point. Local becomes absolute. Therefore, we are going to go with the second derivative test and use this one and differentiate again to show this is going to be a max or min. So having said that, s double prime, negative times negative is positive 256,000 x to the power of -3 plus 2. And so that means 256,000 divided by x cubed. Remember, you have to evaluate this at the critical point. So s double prime of 40 is 256,000 over 40 cubed. You don't even have to evaluate this to know this is positive, plus 2 is positive, and positive means concave up, means minimum because it looks like that. So minimum occurs when x is 40. So if x is 40, you put it here, 40 squared, 1600, divide 32,000 by it, you get the h. Therefore, x is 40, h is 20, so you're right. This is 40, this is 40, this is 20, and you're done. However, if they want the minimum amount, you plug in and you get 4,800 square centimeters. Find the area of the region that is bounded by the following 2 graphs. So first and foremost, you want to graph them. This is a line y equals 2x plus 1. This is a parabola, so everybody can graph it. I don't think anybody has any problem with that. Number 2, you want to find the point of intersection, so set them equal. And we're going to move things around. We can drop the 1 and factor the x out. and x is either 0 or 2. So you plug in 0 in one of them. For example, this one you get 1 here, and you plug in 2, you get 5. So those are the points of intersection. We're going to evaluate it. And so you have to come up with an increment of an area. I'm going to call it dA is H dH. So this one is y of the top minus y of the bottom. And if you look at this, you're going to swoop it across the x-axis. That's y dx. So the top comes from the line 2x plus 1. The bottom comes from the curve x squared plus 1. Okay. You simplify this. Okay. And this one cancels out this one. You get 2x minus x squared. This is x squared minus 1/3 x cubed. And you evaluate it, and you end up with 4/3. And we're done. However, let me quickly show you a second method, because this, although the line is completely at top of the curve is completely on the right side as well. So now this HDH can use x of the right minus x of the left. So we have to write this as a function of x and this one as a function of x. So G minus H, this is the difference between the two, x of the right minus x of the left. So this one is y, we're going to solve for x. This one is y, we're going to solve for x. Please understand, this one is easy, right? Move the 1 and divide by 2. This one, there are two answers. When you have a parabola, everybody, this side is positive, this side is negative. So there are two answers, but we use because this side is the positive side, okay? So having said that, we want the integral. Now, of course, previously, we would swoop it across the x-axis, now along the y-axis, so from 1 to 5. That's important to know. And I'm going to assume you can, integrate this. I'm going to quickly go over the concept. For this one, we're going to use the u substitution y minus 1, and this is y minus 1 to the power of 1/2. Okay. So if you differentiate, you get the same thing. Du and dy are the same. Therefore, u to the power of 1/2 du, and this is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. The limits, you have to plug in the limits. Okay. So if I put the 1 in here, this becomes 0. If I put the 5 here, I get 4. Okay, I hope you see that. 2/3 u to the power of 3/2. You plug in, you evaluate, you get 16/3. So that's this part. We're going to work on this part, and then the difference is the answer. So half of this one, this is very straightforward. 1/2 y squared minus y. 1/2 times 1/2 is 1/4 y squared. And then you can write the 1, if you use 1/4, then this becomes 2. So class, you can see 1/4 y squared minus 2y. And we plug in 5, we plug in 1. 5 is 25 minus 10, and 1 is 1 minus 2, and we end up with a 16/4, which is 4. The difference between the two is the same answer as we got in the previous, and that's the final answer.